direction coupler. Earlier we done the circulator and isolator. The same setup we are going to start the second experiment. Now here also block diagram, that setup without our procedural load. This is the direction coupler load is there. Here there is a 4 ports are here. This is the port 1, this is the port 2, port 3 and port 4. Port 4 is the fixed magic termination. This load we are not connected to the bench. Earlier bench setup, whatever is there, same here also without your procedural load. Klystron power supply and Klystron mount, Klystron oscillator, isolator with magic termination. This is the variable alternator and waveguide or detector mount. Here also we are not measuring any frequencies. That's why we are not using the cavity meter. We are not using this cavity meter or frequency meter. We are not measuring any frequencies in this experiment. That's why I remove this component. Now same procedure. Selected AM modulation mode and frequency and amplitude knobs keep it at maximum before tuning the power supply. And this is selected beam voltage position and beam voltage keep it initially at minimum, repeller keep it at maximum. This is the setup of the power supply before switch on, and this has the input and output. SWR meter is selected 30 dB middle range, and this is selected normal mode. Force and gain control knobs keep it at maximum and set your crystal diode mode. And now switch on your supply, power supply, and set it beam voltage at 300 volts. Now 300 volts or beam voltage. Switch on VSWR. See, without our procedural load, this direction coupler, you set it reference 0 dB where you observe in the SWR. For that you do the tuning in the power supply. You start from repeller voltage. It is maximum is there. First deflection where you see maximum deflection here only. There you leave it. That is at the time our repeller voltage at 128 volts. And you set the frequency from maximum to E decrease towards 0 where it goes. There you leave it. That is the tuning of the AM frequency. This is exact at 0 dB. If it is beyond 0 dB, you set it with the help of variable alternator and set it properly towards 0 dB. And then go for the AM amplitude, do the tuning from maximum to gently decrease and see the deflection towards in SWR where it is the 0. This is the 0 position, this is the better position, you leave it there, this knob, and set it finally with the help of variable alternator and set it to 0 dB in the SWR meter. Now without our procedural load, I set it our reference 0 dB in 30 dB scale in SWR. Here also earlier what you done in circulator isolator, same procedure. You remove your waveguide or detector diode and connect to the directional coupler. This has your load, and remove this component, detector mount. Now here also we are using two loads. One is your output load detector mount and another one is the match termination. Here you observe the physically three ports, and fourth port is the fixed match termination. One has input always after the variable attenuator. Output always comes to the detector mount, and another port we connect along with the match termination. So now I am going to connect this. Use one more stand. Use these two stands and you properly fix it. Now port 1, direction coupler port 1 I am connected as the input port. Fix it properly without any gap. Input port. And output port I am going to connect to the second port. Here also fix it properly. Your second port as output, and third port you see the proper hole matching. This is the rectangle hole, and this also rectangle hole. Rectangle to rectangle you put it. Don't put like this. You put it properly, that hole matching, and fix it. And this also fix it properly, and see the reading. 1 as input, 2 as output, and port 3 is the match termination. In ideal condition 1 to 2 you are supposed to get it 0 dB. Same thing we observe in 30 dB. Our reference is there. Here you got the 0 dB. That is the reading. And again we change the ports. 2 as a match and 3 port we connect as a output port, your waveguide detector. In ideal condition 1 to 3 is the minus infinity, and practical reading we are going to see now. Port to this output port I am going to connect to the third port. Actually this is the coupler value. Whatever you connect the coupler value you can see now. You fix it properly. Output port towards to the 3. In second port you connect to the match termination. This also fix it properly. Now 1 as an input and 3 as a output, 2 as a match termination. Here in ideal reading we in this setup, in this port 1 as input, 3 as output, 2 as a match termination. You see the reading in our reference scale at 30 dB, reading is exceeding more than 10 dB. That means when range is exceeding, we go to next scale, another 10 dB is adding. That means 20 dB is exceeding 20.2 in 50 dB scale. 30 in 30 dB 10 is exceeding, in 40 another 10 is adding, in 50 it is 0.2 is there. Just simply from 0 to 1 division is there. That means 20.2 dB reading is here, minus 20.2 dB, where 1 as input, 3 as output. This is our coupler value. This coupler value is the 20 dB coupler. By doing this experiment, you can find the coupler value at 20 dB. Now here observe the reading minus 20.2 dB. This is the coupler value. Like that, you go for next port reading and dismantle. Again you dismantle this, you remove the loads and connect 2 as an input. Now I interchange the connections, 2 as an input, as an input and 1 as an output. Maximum రావాలి రీడింగ్ కరెక్ట్. You fix it properly, your output load without any gap, and port 3 you connect as a match termination. See the proper hole matching and fix it this also properly. You check your reading in SWR. Port 122 or 221 is the maximum, that is the 0 dB in SWR scale. That is your reference scale at 30 0 dB is there. Now here 122 or 221 you got the 0 dB. Now I am going to interchange these two readings with these two, that means this third port and port 1 I am going to interchange. This as a output, this as a match. Now I am going to connect the output load towards to the third port. Fix it properly. And matched connect towards to the 1. Now power is going from port 2 to 3. Now reference at 30 dB, scale is exceeding more than 10 dB. In 40 also it is exceeding more than 10 dB. In here also you got the 20.1 dB. Now it is minus in this scale 50 dB scale, you got it minus 0.1 dB is there. Earlier 30, 10 is there, in 40 another 10, 20.1. Minus 20.1 dB is there, where port 2 as an input and port 3 as a output. 1 is the match termination. With the help of these readings, we can calculate our S matrix. Finally, you check your reference with the help of alternator, with the help of detector mount, you check it your bench setup, your reference is correct or not. Again, this is set it to 30 dB scale and check it your reading is correct or not. It is maintained your reference at 30 dB only. Initial 30 dB reference is there. At the end of the experiment, after removing your loads, you check your reference. It is not varied. It is at 30 dB only. Whatever in between you connect your load and take your readings is the parameters of your experiment. For your S parameters, your experimental readings is that.